Hi everyone, welcome back to MidZ Academia. So please don't forget to like our videos, share so that other people too can be able to benefit from these online tutorials. So our main discussion today will be based on dynamics, which is force and motions. So the main thing that we need to talk about here, we firstly explain the concept of don't mind my mind addressing because of the code. So we need to talk about the main concept of the force and motion itself. We have already explained what we mean by motion. We said motion is the changing of position with respect to time. So if an object or if a body move from one point to another with respect to time, that one is called motion. Then at the same time we need to talk about force. So force is either pull or push what an object experience. Either, for example, let's say you can see I'm taking the marker and I was able to move my hands anyhow I like, so I'm using force. Or let's say I want to lift an object from the ground up. What I will apply is called the force. You understand? So the concept of the two, of talking about the force at the same time the motions, is what we call dynamics here. So the motion is the when an object changes position, the changing of position of an object or a body with respect to time. Then at the same time, the force either pull or push what an object experience or what a body experience. So the study of an object motion with respect to their forces is what we call dynamics, while the other one, without considering the forces, is what we call kinematics. So there are two terms. We have kinematics, at the same time we have dynamics. So this one is studying the motion of an object with respect to their given forces. Respect to given forces. So why this without force? That's the two difference between the two terms. But if you check the materials, we define all these terms, give an example so that you can get more knowledge about these dynamics and kinematics. So with this, here we'll be talking about the concept of motions, the Newton's law of motions, and how are we going to make use of them one after the other. Newton's law of motion. Newton's law of motions. So in physics, the law is up to like 3. We have Newton's first law of motion. At the same time, we have Newton's second law of motion as well. We also have Newton's third law of motion. So from the first law, Newton's first law of motion, Newton's first law of motion. So that one was trying to explain the concept of when an object is at rest. The law states that a body or an object will continue to be in a state of rest unless if it is acted upon by external forces. What does that mean? For example, let's say if you look at this object, let's say I have this marker here. You can see the marker is an object. It will continue to be at rest unless if it is acted upon by external forces. If I apply forces to move it, of course, it will change the position from one point to another. So everybody or every object will continue to be in a state of rest unless if it is acted upon by external forces. That's what the first law was trying to talk about. Then after that, we also have Newton's second law of motion. That one is just talking about the accelerations and the force applied. Newton's second law of motions. Newton's second law of motions. That one was trying to talk about the acceleration of the force directly proportional to acceleration. So meaning here we can have F is equal to ma. This one is also common, where our F is force, the mass is the mass, this is the mass, and A is acceleration. It's of two cases. If you make the previous video, we talk about the difference relationship between or relation between acceleration and gravity. We said in physics, in some cases A is equal to G. G is nothing but acceleration due to gravity. So, but if you check the materials, we define all this, we mention all these 3 laws so that you'll be able to know what the law was trying to talk about. So our main target here is how are we going to perform calculations involving this second law. So from the theorem itself, we have force is equal to ma, that is mass times accelerations. Now we have a case for this. Let's derive a simple expression for that. So from here, we said F is directly proportional to the accelerations. So by changing this sign, we have it to be F is equal to ma. So F we have here is force. The m is referring to the mass, and at the same time, the a that we have here, it simply means acceleration. So from here, we can derive another formula from there. You see, what we have here is force is equal to ma. If you recall from definition of acceleration, we talk about that one in another equation of motion, right? Yeah, good. We said acceleration is a changing of velocity with respect to time. That is where a is equal to change in velocity over time, and from here we say that a can be equal to v minus u all over t, rather. So where v is our final velocity, the u is initial velocity, and t is the time taken. We explained that one in detail, so in case if you missed the previous video, you can watch that one to understand the concept of speed, distance, displacement, and acceleration as well. So now from here, since I know that my a is equal to v minus u over t, I can make a simple substitution here. If I substitute the value of a to these equations, that means I can have force is equal to m. So instead of writing a, we can write v minus u all over t. So those are the two formulas. You can see we derive another formula from the first equation. So the first one, you can apply the first one. Maybe you have to find the force and the value of mass of the body or of an object is given, and at the same time the accelerations. Or here, if you have to find either velocity, maybe either final or initial, you are given the force, mass, and the time. You can apply the second one. Even from here, we can also derive what we call momentum from here. If I cross multiply from here, I can have ft equal to, that is f times t, and we have ft is equal to m bracket over v minus u. In physics, this f times t, we call it impulse of momentum, and this, we call it a change in momentum. We are coming to that change in momentum. We are going to talk about momentum itself and see how we can perform some calculation, or how we can solve a problem involving momentum. So now from here, so in some problems, you may be asked to find the momentum, and if you are given the force and time, you can just quickly apply this formula. But if you are given the value in terms of mass, final velocity, and initial velocity, we apply the one we have at the right hand side. So meaning from this Newton's second law of motions, we are able to derive let's even say from here we can derive like 4 equations. The first one, we have F is equal to ma. So this can be applied when we have to find the force or the mass or the acceleration. We can make any of the three as the subject of the formula. So the second one, then from here we know that acceleration is a change in velocity over time. So by changing the value of acceleration from here, we know a is equal to v minus u over t. I break it down yesterday that when we have a is accelerations, and when we have v is nothing but the final velocity. When we have u is nothing but initial velocity, and when we have t, is the time taken for the object or for the body to move from one point to another. So now, by substituting the value of a to this equation, then we have f equal to m. So instead of writing a, we write our a to be v minus u over t. So I substitute the values v minus u over t to that equation. So it depends on the problem you are solving. If it's related to the first one, you apply the first one or the second one. So before we move to the Newton third law, let's take a look at 1 or 3 examples and see how we can make use of the formula. So what we derive now, we have the first one we have is F is equal to ma, and we have F is equal to m bracket of v minus u all over t. So those are the 2 equations that we have. Now, let's look at this problem. They said question 1, a net force of magnitude of magnitude is 0.6 Newton act on a body of mass 40 gram. Then also calculate the magnitude of the resulting. Calculate the magnitude of the resulting acceleration. So now let's look at this problem and see how we are going to make use of the of the approach. Now they said a net force of if you miss our previous video as well, we talk about the unit. We talk about the unit. I said unit is what we use to recognize a given quantity. Remember that? Yeah, fine. So now in some situation in physics, if you are writing out the data, knowing the unit is also important, because if you cannot recognize the unit, there will be a little problem. So now, let me just break it down here. We know force is measured in what? Yeah, Newton. Force is measured in Newton. It is denoted by capital N. What of mass? Mass is measured in what? Yeah, gram or kilogram. What about A? It is acceleration. It's measured in what? Good. Meter per second square. So those are the things that we need to know. So now, and I told you conversion too. Please, if you missed the previous video or our previous video we discussed on that motion, just kindly watch it so that you can be able to understand the concept of the unit and what related to it as well. So now, conversion too is very important. You'll be given a value in gram and you will be asked to convert it to kilogram. So normally, we know 1,000 gram is equivalent to 1 kilogram. Meaning, if I want to convert a gram to kilogram, I will just take the value and divide it by 1,000, because I know that 1,000 gram is equivalent to 1 kilogram. For example, if I want to convert, let's say I was given like 1,000 gram, or let's say we are given 2,000 gram, and I want to convert it to kilogram, for example. So I'll just take the value 2,000 gram, then divided by 1,000, because 1,000 gram is equivalent to 1 kilogram. So 2,000 divided by 1,000, of course, we are going to have 2 kilograms. So most of the calculations in this aspect, if you are given the value of your mass in gram, you must make sure that you convert that mass from gram to kilogram. So let's take a look at this. Let's write down the data. They said a net force of magnitude is 0.6 Newton. You can see they did not mention that is it force, is it mass, or acceleration. But since you know the unit, that for the Newton is for the what? Yeah, it's for the force. Good. So that means we are given the force to be 0.6 Newton act on a body of mass 40 gram. So we are given the mass to be 40 gram, but you can see the mass should be in kilogram, and we know that 1,000 gram make 1 kilogram. So meaning here we have 40 divided by 1,000. So here, if this cancel this, we have 0.04 kilogram. They now said calculate the magnitude of the resulting acceleration. Meaning, I'm looking for the value of A. So from the formula we know that F is equal to MA. So now if you like, you can make what you are looking for at the subject, or if you like, you can make a direct substitution. So the force we have is 0.6 is equal to the mass we are given here is 0.04, then A. So now I'm looking for the acceleration divided by 0.04, 0.04. So now if this cancel this, we are going to have A equal to 0.6 divided by 0.04. I think there, I think we are going to have 15. But let's convert with our calculator first so that we don't have the wrong result. 0.6 divided by 0.04. So yeah, of course, what we have is 15. So that means our acceleration here is 15 meter per second square. So you may come across a problem where you may be asked to find the value of force. You may be given the mass at the same time the acceleration. You just apply the same formula. So let's take a look at another examples. Let's take a look at another examples. So that you see how you can make use of the formulas. Let's take a look at another example from Kwara State University. Here they said a truck, question 2, a truck of mass 3,200 kilogram moving with a velocity of 10 meter per second increases its velocity to 20 meter per second in 5 seconds. In 5 seconds, they now said calculate the magnitude or calculate the force on the engine. So calculate the force on the engine. This is another problem. Let's take a look at how we are going to approach that. I hope you are following, right? Yeah, very nice. You can see it's just that the only thing you need to do for the physics, what matters most is the unit. So please, you need to watch the previous videos when we talk about the unit, measurement, and dimension. We talk about the unit very well. So please, in case you missed that, just check that one. The unit is what we use to recognize a given quantity, because in some problem they might not state that particular quantity, but once you know the unit, then you are done. So now let's take a look at this. Let's write the given data out first. They said a truck of mass 3,200 kilograms. So meaning our mass is at 3,200 kilograms. Do we need to convert the mass here? No, of course, because the value of mass is in kilogram. But assuming I told you earlier, if your mass is in gram, what do you need to do? You just convert it to kilogram. So now, moving with a velocity of 10 meter per second increases velocity to 20 meter per second, meaning our initial velocity, the first given velocity, is at 10 meter per second, and the final velocity where it increases to is at 20 meter per second. In 5 seconds, the given time to be 5 seconds, they now said calculate the force on the engine. So now, if I ask you now, which formula are we going to apply with this data? Are we going to apply the first one, or we are going to apply the second one? Which one are we going to apply? The first one or the second one? Yeah, of course, we are going to apply the second one. Why are we applying the second one? Because if you look at the first data, we have to find the force, fine. We are given mass, but do we have acceleration? No. So if you look at the second one, we are given mass, we are given final, initial, and time, meaning we can quickly apply the second one. So therefore, if I apply the second one, I have F equal to M bracket over V minus U all over T. So now we can have this one to be, so the mass given to us is 3,200, open bracket. Our final velocity given to us is 20 minus, initial is 10, divided by the time we have is 5. So here we can have F is equal to 3,200, bracket of 20 minus 10. Of course, we are going to have 10 all divided by 5. So here, if I like, I can just call this one down, or if you like, you can say 3,200 times 10, then divided by 5. Or if you like, you can cut it here from here, 5 here 1, 5 here 2, then I can have F is equal to 3,200 times 2. Of course, we are going to have 6,400 Newton. You can see that applying that formula is just so simple. Just know the concept, understand the problem. The data you have on that particular problem will determine either you are going to apply the first one or you are going to apply the second one. I hope you are following, right? Very nice. Let's take one more question from Federal University Dusabe Materials. They said, let's take a look at this. Take a look at that. A question from a Federal University Dusabe Materials. They said that A towing fan tows a car of mass 1,500 kilogram along a level ground and accelerate at 0.5 meter per second squared. What is the tension? What is the tension? What is the tension in the towing string? So let's look at this. This is another problem. They said, let's solve it together so that how we are going to make use of that. A towing fan tows a car of mass 1,500 kilogram. So you know the first thing in physics, you firstly write out the given data, the data given to you from the problem. So of mass, the mass we have is given as a 1,500 kilogram along the level ground and accelerate at 0.5 meter per second square. So we are given A 0.5 meter per second square. They now say what is the tension. If you recall, in chapter 1, we talk about the tension. We said tension in physics is nothing but force. So meaning we are asked to look for the value of our force. So now, if you look at this data, which one are we going to apply between the two? Are we going to apply the first one or we are going to apply the second one? Can you check which one is suitable for this problem? Yeah, we are going to apply the second one. So the second one and the first one rather, our first one to be F is equal to MA, right? So now we have force to be equal to the mass given to us is what? Is what? 1,500. Good. 1,500 multiplied by acceleration we have here is 0.5. So if you multiply this by this, we are going to have 750. This one is 750. You understand that one, right? So the data you have, it depends on the problem you are solving. Either it includes the first one, which is acceleration in terms of mass, or we have mass, final velocity, initial velocity, at the same time, the time given. So let's solve one more examples. The one related to the friction, because in that material we still have one related to friction. You know, in physics, friction is the force that opposes let's say it's just the frictional force, or let's just say to make it easier, it opposes motion of an object. You understand? Like all those that used to plant on the road, it opposes the motion of an object. So let's have one more, then we move to the next agenda. Boss. Now, they said if a horizontal force X Newton acts on 100, or let's say, can I just reduce the value? Let's just say 1,000, so that's 1,000 kilogram truck, and give it 2.2 meter per second squared acceleration on a plane with coefficient of friction is 0.15. Then answer, find the value of force, that is the X Newton that we have from the problem. You see here, So here I just have to explain the main concept of that so that you'll be able to know how you are going to solve this one. You know, on the norms, we know that here what you need to do here is resulting force must be equal to applying force here. Resulting force must be equal to apply force here. I will explain the concept so that you get that one. Apply force. So what do you need to do here? Recall that we said force can be equal to ma. Do you remember this? Yeah, from what we derived the other time from the Newton's second law of motion. So we know that in substitution, A can be equal to G. Okay, maybe we are asked to take our G here. Let's say we are asked to take our G here to be 9.8 meters per second squared. So resulting force must be equal to applied force here. So now that means this formula can still be decreted as a F equal to M. So instead of writing A, we want to include G now. So F is equal to mg. So you know they mentioned friction here. Friction in physics is the force that oppose the motion of an object. Just like down below planting on a road, so it's opposing the object to move. So let's firstly write down the data. The force is given as x Newton act on a 1,000 kilogram truck. We are given the mass to be 1,000 and give it at 2.2 meter per second as acceleration. We are given a to be 2.2 meter per second square then, and we are given the coefficient of friction, so which is mu. In physics, mu is friction. We are given the value to be 0.15, and now the problem says find the value of F, which is x Newton. So I told you earlier, resulting force must be equal to the applied force, meaning we can have this one to be F, which is ma, which is equal to x minus mu, then F. This F, where F of that we wrote here is going to be equal to mg. So meaning if I want to interpret this, because the resulting force must be equal to what here? The applying force. So down here we have ma is equal to x minus mu. Our F is equal to mg. So now, by making our x as the subject of the formula, if I collect the like terms, that means that we have ma. So this is minus. So when the minus comes here, we are going to have plus mu mg equal to x. So let's substitute the values one after the other. From the problem, we have mass to be 1,000. That means that we have 1,000 multiplied by our a that we have is 2.2. This 2.2 plus the coefficient of frictions that we have. As our friction, we have it to be 0.15 multiplied by the mass we have is still 1,000 multiplied by the g that we are given from the problem. We are asked to use 9.8. Then everything is equal to x. So please, you should use your calculator to check the result of this. If you do that 1,000 multiplied by 2.2, of course, you are going to have 2,200. So here we have 2,200 plus 0.15 times 1,000 times 9.8. Then for this, we are going to have 1,470 equal to x. So if you add the two together, so we have our force to be equal to 3,670 Newton. So I think in the material they leave their result in terms of kilonewton, meaning you can divide this value by 1,000. If you ask to leave your result in terms of kilo Newton. So that's all about what we have for Newton's second law of what? Newton's second law of motion. Another one we have is a Newton third law. That one is also simple and straightforward. It's just a law that actions and reactions are equal and opposite. So you don't need to perplex. We are going to release material for this and I'll break it down, the first law, the second law, and the third law with their respective examples. So let's move further. After that, we have work done. This one is also common. Work done and energy, work done and power. This one is also simple and straightforward. Work done and power. Work done. So when they ask you what is work done, is what you have learned when we are in secondary school. What is work done? Work done is nothing but the product of force and the perpendicular distance. So work done. I will take them one after the other. I will take for work done. At the same time, maybe I should add this one to it. I'll take work done, energy, and at the same time, the power. And all these things are just straightforward. So for the work done is nothing but the product of the force and the perpendicular distance. For example, let's say I want to lift an object from point. Let's say this is a man. Let's say this is me. Okay. So this is a block that we have on the ground, a big block. Let's say my body weight, let's say 100 kg, for example. You can see how big I am, right? So now let's say the block just reached 2 kg. So assuming I want to lift this block from the ground, what did I need to apply? Yeah, of course, I will apply the force. Of course, the object itself, I will carry it from one point to another. Maybe I want to carry it up here. Definitely, it covers some distance. So, just like literally, the work done is the product of force and the distance. It is force and distance. Let me write it in full. So we can say work done. You can see that work done is equal to force multiplied by distance. So, and I told you some material, they use D for distance, or they can use X. So meaning we can have work done here to be equal to F times X, or they can denote it as F times D, which is force times distance, or force times X, with X, where X means distance. So the unit of, let's derive the unit for the work done. We know the force, you say work done is equal to F times X. We know that force is Newton. Then at the same time, the distance is meter. So that means the X unit of work done is a Newton meter. But at the same time, it's also called joule, because work done and energy, they are the same. So we can also use a work done to be either joules, or we use a Newton meter. So under vector, we talk about when an object moves either horizontally and vertically. You recall that if you are resolving an object vertically, we are using sine, and if you are resolving it horizontally, we are using cos. So, meaning here, let's say I was asked to find the work done. In some problem we can encounter such situations. Maybe we are asked to find the work done, and we see that the object is moving horizontally. So we can just have the formula to be work done equal to force times distance cos theta. Remember under that one, we say if you are resolving them vertically, we are using sine. You remember that? Yeah, good. So when we are resolving them horizontally, we are using cos. So maybe we have to find the work done, and the object is moving horizontally. Then of course, the formula can just be written as a work done is equal to force multiplied by d, then multiplied by cos theta if the angle is included. I think this one is straightforward. Maybe we should just solve one example, then we move to the next agenda. So here they said a body is pulled along a horizontal plane, by a constant force, of 10 Newton. So the first question they said, calculate the work done in moving the body the distance of 20 meters. As the first question, the room have got 2. Let's assume they said find the work done. Maybe they said find the work done if the same force is applied. If the same force is applied to the body at an angle at an angle of, let's say, 60 degree to the horizontal. To the horizontal. And cover the same, and covered the same distance. So let's look at this and let's see how we can we are going to obtain that. It's simple. You don't need to worry about that since you have us here. This is our Medici Academia. We are here to break down a problem that is solvable, unless if the problem is not solvable. As far as the problem can be solved, we are here to help you to break down the particular problem. So now they said a body is pulled along a horizontal plane by a constant force over 10 newton. You know, I told you in physics what matter most is to firstly write out the given data. So now data we have here, given data, we are given force to be 10 newton. Now the first question is said find the work done. We should find the work done given that you're moving the object at a distance of 20 meter. If the distance is 20 meter, right? So now recall the formula for work done. We know that work done is nothing but force multiplied by distance. So now I can have this one to be work done equal to, so our force given from the problem is 10. So multiply by the distance we have is 20. So now if you multiply 10 by 20, of course you are going to have 200. So it's either you use Newton meter or you use joule. It depends on the answer, the result that you want your result to be. So I told you earlier, the work can either be Newton meter or can be joule, because the two are still the same, because work done and energy are the same. So you can say joule here, or we can use Newton meter. So the second problem, they said we should find the work done again. We should find the work done if the same force is applied. That is, if they maintain the value of force. What is the value of force we have here? We have the force to be 10 newton and at an angle of 60 degree. That is, if the angle now is 60 degree, at the same time, it covers the same distance. What is the distance given to us? 20 meters. So if our distance to the mean is at 20 meters, so you can see now, they now said to the horizontal. You can see they include that. So when we know that if it is horizontal, we are going to apply. We're going to apply the first one or the second one. Yeah, fine. So that means we have F is equal to work done. Work done is equal to force times distance times cos theta, since the angle is included now. So that means here we have work done equal to, so the force that we have is 10 multiplied by the distance we have is 20 multiplied by cos, the angle we have is 60 degrees. So now I can have work done here to be, so 10 times 20, we are going to have 200. Now if you check your four-figure table or calculator for cos 60 is nothing but 0.5. So 200 multiplied by 0.5, we are going to have 100 joules. So that's all about this case. So